Question 3, Part C. In the diagram, A, B and C are the points 6, 0, 9, 0 and 12, 6 respectively. The equation of the line OC is x minus 2y equals 0. The point D on OC is chosen so that AD is parallel to BC. The point E on BC is chosen so that DE is parallel to the x-axis. Part 1. Show that the equation of the line AD is y equals 2x minus 12. To find the equation of a line or an interval, in this case interval AD, we need its gradient and we need a point on that interval. Now it's given that AD is parallel to BC. Now with interval BC, we have two known points, so we have point B and point C. So we can work out the gradient of BC, knowing that AD is parallel to BC, so whatever the gradient is here, AD will be identical to that. So let's work out the gradient of BC. So using the 2-point formula, it's given by the change in y divided by the change in x. So 6 minus 0 in brackets divided by 12 minus 9 gives us 6 divided by 3, which equals 2. Now since AD is parallel to BC, which I've stated up here, the gradient of interval AD is equal to 2. Now the point A, 6, 0, lies on AD. So that's our known point. So using the point gradient formula, that is y minus y1 is equal to m times x minus x1 in brackets, we get y minus 0 is equal to 2 times x minus 6 in brackets. Expanding the brackets on the right hand side, we get y is equal to 2x minus 12 as required. Part 2. Find the coordinates of the point D. The point D lies on OC and AD. So to find the coordinates of point D, we need to solve simultaneously the equations of OC and AD. So we're going to solve simultaneously x minus 2y equals 0 and y equals 2x minus 12. So I'm going to employ the substitution method here. So in this equation, x minus 2y equals 0, I'm going to substitute 2x minus 12 for y here. So we get x minus 2 times 2x minus 12 in brackets equals 0. Expanding the brackets on the left-hand side, we get x minus 4x plus 24 equals 0. Combining the like terms, we get negative 3x plus 24 equals 0, which gives us 3x equals 24. Dividing both sides by 3, we get x is equal to 8. Now from the equation y equals 2x minus 12, if we substitute 8 for x, we get the y coordinate of point D. So y is equal to 2 times 8 minus 12, which gives us y equals 4. Therefore the coordinates of D are 8, 4. Part 3. Find the coordinates of the point E. Consider quadrilateral ADEB. Now opposite sides are parallel, which makes ADEB a parallelogram. And because it's a parallelogram, AB equals DE. Now AB sits on the x-axis, DE is parallel to AB, which means DE is parallel to the x-axis as well. That means the y-coordinates of points D and E are identical. So the y-coordinate of point E is 4. Now consider point B in relation to point A. Now B is 3 units to the right of A, which means E is 3 units to the right of D. So the x-coordinate of point E will be 11. This item is only worth 1 mark, so we only have to quote the coordinates of point E to gain the mark. But it's good practice to write a brief explanation as part of the solution. So ADEB is a parallelogram, hence DE equals AB, and DE is parallel to AB. Now B is 3 units to the right of A, hence E is 3 units to the right of D. Therefore the coordinates of E are 11, 4. Part 4. Prove that triangle OAD is similar to triangle DEC. To show triangle DOA is similar to triangle CDE, we need to show that two pairs of corresponding angles are equal. I'm going to show that angle DOA is equal to angle CDE, and angle ODA, so that's this angle here, is equal to angle DCE. I'm going to use parallel line theorems to prove this fact. So in triangle OAD and triangle DEC, angle DOA is equal to angle CDE, and the reason is corresponding angles, DE is parallel to OB. Angle ODA is equal to angle DCE, and the reason is corresponding angles, AD is parallel to BE. Therefore, triangle OAD is similar to triangle DEC, and the reason is equiangular. Part 5. Hence or otherwise, find the ratio of the lengths AD and EC. The ratio AD to EC is equal to the ratio OA to DE. And the reason is corresponding sides of similar triangles are in the same ratio. Going back to the diagram, the length OA is 6 units, the length DE is 3 units, hence AD to EC is equal to 6 to 3, which simplifies to 2 to 1. Therefore, the lengths AD and EC are in the ratio 2 to 1.